बंद कर दूं रिकॉर्डिंग, अभी से स्टार्ट कर दूं द न्यू रिकॉर्डिंग?
हाँ fresh we can start.
ओके, पेन QoS topic QoS. So many of you already know why QoS is required, but what I told you earlier, it was not required, but today it's mandatory. Today it's mandatory because guys, earlier what I told you, for an example, I have two sides. This is my DC or headquarter or the head office. Here I have one switch in the DC, some employees are there, all are connected through this switch, and let's say this switch is connected to one router, and now I want to connect this network to WAN, right? To connect another side or to provide internet access over here to this side, to the headquarter or DC or any branch. Switch 1, for an example, PC1, PC2 and PC3. Connected like this. So nowadays, how we are connecting two sides? Internet, mostly we are using internet only, right?
Correct.
And MPLS. But if I will talk about 20 years back, guys, right, here we can see we have in this side we have different types of traffic. For an example, normal traffic, the general traffic. General traffic can be considered as normal traffic, means the employees want to communicate or the employees want to access internet. Normal traffic or normal data traffic, what we say, normal data traffic. Then here we have internet traffic also. For an example, we need internet access. Here we have internet traffic, right? Before connecting it to the WAN, just I am deciding how many types of traffics are there in my network. So I found that some normal traffics are there, some internet traffics are there, some voice traffic are there, voice traffic, or let's say some video traffic, video conference video traffic, or any different types of traffic. So these are traffics in my network. For these types of traffic, I want to connect my LAN to WAN. I want to connect my LAN to WAN. First of all, let's talk about normal traffic. For normal traffic, I can have connectivity from any service provider, right? Like your lease line, you can have lease line. I am talking about 20 years back, 10 years back minimum from today. So here maybe you have one service provider, multiple types of service providers are there. You can consider any service provider like lease line for an example, and your router is connected to SP. The purpose of this service provider is to carry normal traffic, right? To carry normal traffic between two sites. Another type of traffic is internet. For the internet, I will have one internet connection, internet connectivity from ISP. Here let's say I have one ISP. ISP is for internet access. ISP is providing internet access. Then for voice traffic, I will have again another service provider. I told you what is the name of this service provider. This is my PSTN.
PSTN.
Yes. PSTN is going to forward voice traffic. For the video traffic, let's say I have another service provider 2. For general traffic, I am using Jio. Jio is my service provider here, and here Airtel for video traffic, video conference. So I have two service provider like this. I can say SP2. So do you think quality of service is required here, guys? I don't think so, because we are using a dedicated line for dedicated type of traffic. For different types of traffic, I have dedicated line here. So quality of service is not required. True.
Yes, sir.
But the today's network is not like this. Here now normally I have another side, and the another side is again also connected like this only. Let's say R2, and this router is also connected to all these service provider. At each side I will have these all service provider. What is the disadvantage here, guys? Issue. What is the issue here? Main issue is hello. What is the main issue over here? I am paying to how many service provider, guys? To connect in two side, I am paying to how many service providers?
Sir, paisa, money.
Money, cost. I am paying to SP1, SP2, ISP and PSTN. And there was some more service provider also for different types of needs, for different needs. So for different types of traffic, we were using different types of line. Earlier, 10 years back, 20 years back, for different types of traffic, we are using different lines. Cost is the major issue over here. You know, MPLS is very costly. So today
Yes,
how
sir.
we are connecting two sides? Very simple. Two router, side 1, side 2 and internet. Only one service provider is there, that is ISP, internet service provider. R1, R2, two sides. Right? Here I will have public IP address, for an example 1.1.1.1, and here I will have again public IP address 2.2.2.2 or 1. Both will be reachable with each other. Both are reachable with each other. So now I can create VPN here. Any VPN, doesn't matter, IPsec, GRE. Through VPN we can have reachability for private network. Public reachability is already there, and for private I can have this VPN. Today this is our favorite line between two sides. Right? Now here I have private network. Again, these all types of traffic. Normal traffic, internet traffic, voice traffic and video traffic. And this time the same service provider is going to carry all the traffic, right? Single service provider is forwarding these all types of traffic between side 1 and side 2. So now you tell me, is quality of service required here? Yes, now quality of service is required, because we are forwarding all the traffic through same WAN link. On the same WAN link, I am forwarding all types of traffic. Now, router 1 have to prioritize the traffic, right? Now we have to tell to router that this is voice traffic. Earlier, for the voice traffic, there is one dedicated line. So router already know that, right? All the voice traffic will be transferred over this service provider, this line, PSTN. Right? But now same line is going to carry all the traffic, so QoS is required. Guys, if I will talk about before QoS, without QoS, not before QoS, without quality of service, you know how router is forwarding the traffic. This is so important. To understand QoS, quality of service, you have to understand how router is forwarding traffic without configuring QoS. Like you all know the routing table checks. So if I will talk about without QoS, how router is forwarding the traffic, pent on the basis of, guys, by default, let's say router have not any QoS configured, right? Router is forwarding traffic on default behavior, so it will be using FIFO method. FIFO is what it is?
First in, first out.
First in, first out. What is the meaning of first in, first out?
Yes, correct.
It mean packets are sent or transferred or sent in the order they arrive or receive, right? Correct? No priority. Correct? This is FIFO. Yeah.
And the queuing, right, sir? Queuing, the first packet it's come, it will get the first out.
Yes. If the outgoing interface is busy, let's suppose here I have a router R1.
So this method is followed by router when QoS is not configured, right?
Yes. True. So this is router and let's say two interfaces are there. Input interface and output interface, means where it will receive the traffic, let's say 0/0, and 0/1 is the output traffic, output interface. So what I am saying, if the outgoing interface is busy, how it is possible? For an example, this is my LAN interface. This is my LAN interface, and generally on the LAN interface you will have more bandwidth because here you are not paying to anyone for bandwidth, correct? This is LAN and this is WAN. Right? So on the WAN link, let's say I have 10 Mbps. 10 Mbps. And this is my fast Ethernet link, 100 Mbps. 100 Mbps. LAN interface has what bandwidth?
Higher bandwidth.
Higher bandwidth than WAN interface. LAN interface 100 Mbps, WAN interface only 10 Mbps. So what will happen in this case?
Congestion.
Where?
At WAN port, sir.
How?
So packet will be arriving, but it will be kept in a queue because but the outline pipe is very small, you can say.
Outline means outgoing interface?
Yes.
Okay.
So it will be basically you can say ki traffic would be stuck or a delay would be observed.
Less bandwidth size also.
Less bandwidth on WAN interface can cause what issue?
Slowness, latency,
Congestion,
drops.
network congestion.
Network congestion. Okay. If router is guys going to transfer the data at the same rate, same speed, then definitely WAN queue of WAN port will full. It can receive more data on the receiving interface, but it cannot forward the data from the WAN link at same speed. At the same speed, it cannot forward the traffic. Who is forwarding the traffic from queue, input queue to output queue? Here I have queue. Queue, input queue. From input queue to output queue, scheduler will transfer the data. Input queue and output queue. Output queue. Scheduler will pick data from input queue and it will forward to send it to transfer it to output queue. But size of output queue is going to be smaller than input queue. Is size same? Bandwidth same? No. Buffer memory or queue size depends on link bandwidth. Depends on link bandwidth. So here we can have packet drop on the router. If it is using what? First in, first out. In this case, here we can have packet drop, and we'll never want that router should drop voice traffic, because voice traffic is delay sensitive traffic. One minute guys, 1 minute. Extremely sorry. So what I am saying here, we have lack of bandwidth for WAN link, and you know scheduler will pick data from queue and transmit it to media in high priority queue, like it is going to process the data from high priority queue. If there is any priority in the queue, then it is going to use that, right? High priority data will be scheduled first. Scheduler will pick high priority data first. If there is no QoS, it is going to work on first come first out. And if there is no space in the output queue, if we don't have a space, no space, then there will be loss, packet loss. Because here now my receiving interface queue size is large. Maybe for an example, it can store 6 number of packet, and the size of each packet is, let's say, 1500 bytes. And this router have received this 6 packet. But if I will talk about their output queue. So output queue size can only store 2 data with same size 100 bytes 100 bytes. In this case you can see in my input queue 6 packets are there, in output queue 4 packets are there. If the scheduler is going to pick the fifth one, guys, if the scheduler is going to pick this fifth one, the second last or the last one, to forward it in output queue, there is no space. In this case router will drop the traffic. You know, this is the default behavior. Is it clear? First of all, scheduler will process data from high priority queue first, and if there is no space available in the output queue, router will drop the traffic. What can be the solution? What can be the solution here? The simple solution can be increasing the bandwidth of WAN link, right? Here also I can configure 100 Mbps. I can buy 100 Mbps link, but again guys, it is going to increase the cost. And if this router is going to drop an UDP based traffic, then user will retransmit it, because user sender will not get acknowledgement. As it is TCP based traffic, it will expect acknowledgement. If sender will not receive acknowledgement, then it will perform retransmission. But if it is voice traffic or any UDP based traffic, retransmission is not going to be happen. Right, then QoS comes in picture here. QoS is going to solve your problem. You will configure QoS so that router, like scheduler on the router, should first pick voice traffic. Let's say packet number 1, packet number 2 are general traffic. These are general traffic. In packet number 3, 4, 5, 6, these are voice traffic, critical traffic. But scheduler is going to first put this packet from input queue to output queue. Guys, you know one more thing, like if I've been talking about the default behavior, scheduler will not start processing data transfer from this queue to this queue until and unless a space is available over here. First of all, a space must be there in the output queue, and when this queue, input queue, will get full, after that it will start forwarding. In this case, scheduler will first pick this one, then this one, then this one, then this one, and these two will get dropped. So your voice data is going to be dropped. So with the help of QoS, we are going to tell to router that first send these 4 packets. Right, after, even if this packet will get dropped, no issue, these are the general traffic. So either you can increase the bandwidth of WAN link, then you don't need to configure QoS, or you can configure QoS. If it is data traffic, right, the HTTP traffic, router, like there can be delay more than voice, no issue. But if it is voice traffic, voice is delay sensitive traffic, delay should be less than 100 millisecond for the voice traffic. Even 100 is more, guys. Or actually you will have requirement in the production, you know, like if I will talk about in this case, see, this is my network. Why we need QoS? Let me tell you. This is my scenario. Let's say here I have one server. In the DC I have one server, and on this server I am running one application, app1. App1 is one application which is running on this server, and my employees are working on this application only. Every day when the employees come in office, they access this server, open the application, and they are working there. And here are some employees who is accessing this application every time. So you will have requirement of this application only, right? If I will talk about VoIP, voice over IP. So if you have experience in voice over IP, or maybe if you have worked in the call center, you will find that we are calling a customer through a server, right? On the server, you are going to log in, and there will be option to call on the server. Through server, we are calling anyone. We are not dialing the number. You can dial the number as well through server also. That is called call server. In every company, you will find. Who is responsible for? VoIP, voice over IP. So this server has requirement that, see, if you want to use this application smoothly, then delay must be 10 millisecond. Now in this case, I have to configure QoS. On router number 1, router number 2 should have idea that if I am receiving traffic of this application, I should process that first. If delay is going to be more than 10 millisecond, it will lose the connection to the application. The connection will be terminated. It will not work. So you have to configure now QoS for this. Or you can purchase the required bandwidth from a different service provider for this application only. For this application, for the traffic of this application, I have a dedicated line. Whatever required bandwidth are there, it can increase the cost. So the another option is QoS, and this is the reason why every time we are configuring QoS on in the network, because QoS is required everywhere. Just guys, 1 minute. Yeah. So if the space in outgoing queue or in on the outgoing interface is not available, or the outgoing interface is busy. If the outgoing interface is busy, new packet are enter in queue up to a limit. There will be limit, or otherwise your packet will get dropped.
Sir, I have one question here.
Yeah.
Sir, now this one VoIP network, for example, this LAN and WAN interface, we can configure this QoS. But beyond this ISP, for example, main branch and branch office, between these two companies, there are multiple ISP. Then how the QoS will handle this one?
So in that case, you have to coordinate with service provider, brother. Your service provider, see, from the service provider, when we are going to purchase the connectivity, they will provide me the sufficient bandwidth. Now I am dividing that bandwidth only. That bandwidth is already reserved for my connectivity. Service provider have already defined that amount of bandwidth.
Okay.
And we can configure QoS in service provider network also by coordinating with him. Right?
Okay, sir.
1 minute. Yes. Any other question? The queuing is exactly working like, what can be the example, real-time example? Like the line at the ticket counter. When we are booking any ticket or line in the at the airport for the boarding pass, right? Who will come first? They will process. It is
VVIP.
Yes, it is exactly working like that. And QoS is VIP.
Yeah.
QoS is going to be work like VIP, right? The general line and the VIP line. All clear till here? Till now we have only seen the need of QoS, where it is required. Right, so by default router is forwarding traffic on the basis of FIFO, first come first out, means whoever come first get the ticket first in the ticket counter. Whoever come first will get the ticket first. Exactly like that, router is forwarding the traffic from input queue to output queue. But let's suppose, guys, at the ticket counter there are two persons. One person has flight just after 5 minutes and one person has flight after 5 hours. Are you able to see the difference? One person has flight in 5 minutes and another person has flight in 5 hours. So we should not process on default. We should prioritize. We should give the ticket to person who have flight in 5 minutes first. So by default, without QoS, router don't know the urgency, which traffic is critical traffic, sensitive traffic, delay sensitive. And you know the jitter, delay. What is jitter, guys? Jitter. What is delay? What is the meaning of delay? Many times I said delay, delay, delay. What is delay? Tell
The
me, you guys
time,
have already learned the
time,
CCNA plus CCNP.
time
Almost.
required from time required or time taken by a packet to move from input queue to output queue, basically.
From
Yeah.
one device to another device.
Yes, there are many types of delay, by the way, right? Right now I'm talking about interface processing delay. Time taken by a router to forward traffic from input queue to output queue.
And jitter is something like that's suppose a time taken by a router to move the traffic from input to output queue. Suppose for one packet it has taken 3 seconds. So and for another packet it has taken 5 seconds. And for the third
Yeah,
packet it has
variation
taken
in the
7
delay is
seconds. Jitter.
variation, or you can say gap in the delay is jitter. Very good.
Yeah.
This is on fast Ethernet link, like the Ethernet link behavior. On the serial link, the behavior is different. On the serial link, it is not using first come first out. There is another method called WFQ,
Okay.
weighted fair queuing, the default on serial link. It's set a fair bandwidth for each flow. Each flow. It can automatically detect the flow. Flow means what? Flow means if the source IP, destination IP, source port, destination port, protocol number are same, that will be considered as one flow. And weighted fair queuing can automatically detect the flow, like voice, traffic, file transferring, etc. are assigned to fair queue. Right? We don't need to learn this one, how it is working. WFQ. For the Ethernet it's sufficient, because PQ, priority queuing, is also there, one types of method of traffic forwarding like FIFO. Now let's understand QoS. Hope it is clear why QoS is required.
Yes, sir.
Issue is because, see, why quality of service is required in today's network? Because today,
We are using a single link
yeah,
where different services has to be traveled.
yes, we are saying in another word, you can say it is converged network. Converged network. Today's network are converged network. A small voice traffic have to compete with large files, but voice is our delay sensitive traffic. This you need to keep in mind, that voice is in interview also. If interview is asking you why QoS is required, you can say QoS is required for voice. This can be the best example because voice is delay sensitive traffic. And the another thing is voice traffic is guys very
UDP based.
Yeah, UDP based also, and very less in size. Generally your voice traffic is starting from 15 KB. 50 kbps to 100 kbps can be the size, right? And as voice is a delay sensitive traffic, delay should be minimum. What I told you, delay should be what, guys? Delay should be, for the voice traffic, delays must be lesser than or equal to 100 millisecond.
Sir 150 है वैसे I think book में.
150 है तो वही 150 जो भी इसी के बराबर में, I think 150 सेकेंड. 150 millisecond. This is the requirement of voice traffic. If delay is more than this, then there will be issue. For better quality, maybe you will have bad quality while calling. So delay should be minimum for voice traffic. Like delay is, if delay is 1 millisecond. If delay is 1 millisecond, then user will not experience any delay. Quality is going to be best. So if you will send both the traffic on the same link, like if someone is downloading the movie and someone is working on critical server, then there will be problem.
Issue.
So we should always prioritize our sensitive traffic. And for the voice traffic, jitter should be, if I will talk about the jitter, so jitter should be also, guys, less than or equal to 30 millisecond. You can check the exact number, I think 30 millisecond.
30.
50?
30 है
30 है ना? Right? And delay means processing delay. Right? See, so many types of delays are there, like router is performing encapsulation, decapsulation, so it need at least some time, maybe very less time, but it is required, right? Like L2 decapsulation, L2 encapsulation, that is called processing delay. Then another type of delay can be interface delay. Interface processing delay can be vary. Processing delay can be vary on the device, depends on load, depends on loads, but the interface delay is fixed, that we can configure it on interface, right? The delay with the help of delay command, there is one command delay, and we can configure the delay on the interface. And the gap in delay is called jitter. Right? So we have limit for delay and jitter for the voice traffic. Let's say load on one router is very high, so that router will take some more time, so jitter can increase there. Jitter can increase there. It is like this. The gap over here on this router is same, gap over here is also same, gap over here is also same, but on this router delay load is very high, so this is the gap over here. So this gap is called jitter. This gap is called jitter.
Sir, questions. Sir, we are talking about voice only. So, are we prioritizing only voice traffic or some specific traffic as well in QoS?
No, I am saying sensitive traffic, critical traffic, and voice traffic. Not only voice.
Okay.
Even I told you the application also. Right? I'm talking about all types of traffic.
Okay.
Right? Sometime in the application you will have requirement that packet loss should be less than 1%. If packet loss is more than 1%, then your application will not work. Right? So we can say for the voice traffic, delay should be 150 millisecond, jitter should be equal to or less than 30 millisecond, and loss should be less than 1%. This is for an example 1 requirement. So according to this requirement, we can configure what, guys? QoS. Right? Like the voice traffic who have this requirement, this voice or any application or any traffic should have the sufficient bandwidth. Should have the sufficient bandwidth. Like voice and the video conference. Video conference is also UDP based traffic, right? Video conferencing.
Yes, sir.
And there should be minimum delay. If there is gap, right, if the quality is not good, let's say internet is not working properly, it is going to, even attending this class is going to be irritating, right, for you. If you will not listen me properly, then joining the class, staying here for 2 hours can be irritating. Yes or no?
Yes, sir.
Fine. Now, yeah.
Also some games, gaming application also.
Yeah, gaming application, very good. Gaming application need consistent bandwidth. Continuous, consistent bandwidth. For the gaming application, this is the requirement. So each type of traffic has their own requirement. According to that, we can configure QoS on our router. And now you know the scheduler also, scheduler who is transferring the traffic. Now let's start with QoS. Let me open the new page and let me tell you what is QoS now. QoS works on 3 model. May I know the name of each model, guys? Works on 3 models. Number one is best effort. Best effort. What is the meaning of best effort? The default one. The same FIFO. FIFO means no any QoS. Works on FIFO. First come, first out. And this one is the default one. Default QoS configuration is best effort only. Right? The second model is int serve. Int serve. Here we don't need to learn int serve, but it is used to reserve bandwidth between source and destination. You know RSVP protocol, guys? Do you have idea about RSVP? It works on
what protocol, sir?
RSVP.
Resource reservation protocol.
Yes, yes, exactly. So it works on RSVP, resource reservation protocol, right? It works on per flow again. Works on per flow. Per flow means it will be using a specific bandwidth for a flow. For a flow, if I will give you the example, let's say here is a service provider who is connecting two sites, router, and in both sides, let's say two IP phones are there. How I can draw IP phone? अगर IP phone को ऐसा लगेगा तो बताइए आप लोग.
सर लिखे दो IP.
ऐसे. And this side also. And these guys are talking on call. So RSVP will work on per flow. It means if the source IP, destination IP, port number and protocol number, if these all things are same, that is going to be considered as one flow. If these all values are same, it means this is one flow, and RSVP works on per flow only. Right? Let's say here we have configured the QoS. QoS is running between these two devices. When the first person is going to call to this person, it have used the QoS and it have forwarded the traffic. If it is receiving same traffic from the same user, it will be using same path or same bandwidth. It is like, you know how it is going to work. Let me give you example. See, R1, R2. Person 1, person 2. Person 1 and person 2 want to communicate. QoS is already configured here. One router will receive the traffic, and let's say this traffic need 2 kbps bandwidth here. So router is going to reserve 2 kbps bandwidth between R1 and R2 for this user. Right? Let's say the available bandwidth over here is 1 Mbps. So rest all the bandwidth are available for another users. At the same time, if this user is also going to call to this user, again your router is going to reserve 2 kbps for this user. Per flow, it is going to reserve 2 kbps according to the requirement. And let's say router is utilizing all 1 Mbps bandwidth, and if another user will try to call their friend, any another user, it will forward the traffic to router, and router is going to discard it because bandwidth is not available. All the bandwidths are already reserved to other user, and it will be using this for this user and this user until and unless source IP, destination IP, source port and destination port is same. It will be using this flow only. Let's say this is normal person. Yeah.
Sir, why traffic would be dropped for the third one? Why it will not be treated as a normal
bandwidth is not
traffic?
available.
तो normal traffic में नहीं जाना चाहिए queuing में.
तो total bandwidth ही है ना इतना 1 Mbps.
Okay.
Total bandwidth of this WAN link is 1 Mbps and is already used by RSVP protocol for these employee. Now what I am saying, this is normal employee, just they are joking, 2 person are joking. And here is the manager who need to talk. But if bandwidth is not available, router will discard it. This is the issue of int-served model. Int-served model works on per flow.
Per flow. So if this 2 kbps reservation bandwidth for this telephone only, the first one you mentioned.
Yes.
For that test.
So until and unless this user will not stop the communication, manager cannot call. Int-serve don't know who is the user, which type of traffic I am prioritizing.
Understood.
Right? whatever bandwidth are required, it will reserve the path source. It will reserve the source. That's why we are saying resource reservation protocol. And the third model which we are going to use is called, the last one is called, third one, diff serve. Diff serve. Int serve stand for what? Integrated service model, and diff serve stand for differentiated service model. Differentiated service model, and we are going to use it for our QoS. Okay, so your QoS works in three model. First one is best effort, that is a default one if there is no priority. Second one is interserve, which uses RSVP to reserve the resource. And the third one is differentiated service model, which we are going to use. If I will talk about interserve, so this model is generally used in service provider. Where you will find it? In service provider. Because see, it is working on flow. It is useful in the service provider network. We will work on diff-serve model. Diff-serve model. Here we will not configure quality of service on the basis of per flow. How we will configure quality of service?
Per class, I think.
We can reserve bandwidth on the basis of source IP, destination IP, source IP, protocol, traffic type, etc. On the basis of traffic type, we can configure QoS here. It is voice traffic, prioritize it, write forward it first, like that. Not on the basis of flow.
Sir, so MPLS is a second type of method, it will work maybe.
Yeah, 100%. Interserve. Right. In the deep serve, we can say voice traffic should have 2 Mbps link, let's say. We can say this application should have 2 Mbps link. Right? FTP should have 500 kbps bandwidth, 512 kbps. Like this, you can configure QoS. And what we need to learn in quality of service, guys, see, you need to learn classification and marking, we can say. You need to learn traffic shaping, shaping and policing. Then you need to learn the congestion. Even congestion is not in our syllabus. You can learn separately. Congestion management, and then congestion avoidance. This is the major part of QoS, quality of service.
It comes under diff serve, sir.
Yes.
Model.
Okay, so first of all, classification and marking. Marking can be done at layer 2 and layer 3, where we can mark the traffic. Marking means what? Adding the label with traffic, right? Through marking only we are going to prioritize the traffic. So we can mark at layer 2. Marking can be done at layer 2 and layer 3. Sometimes you can say layer 2.5 also if you want to say. Classification and marking at layer 2 on a single switch is not possible. Is it possible, guys? Can I mark the traffic at single switch? See, I have one switch here and some employees are there. Can I configure quality of service here? Where you will configure quality of service?
So
If
suppose the
any two
service is
user,
there on the same site.
if
Suppose the
any two
server is
user
there.
want to communicate, they will communicate via switch 1 only. Right? Here marking cannot be configured. We cannot configure QoS. But if I have two switch 1 and switch 2, and link between switch 1 and switch 2 is,
Trunk.
what should be the link? Trunk.
Trunk.
So on the trunk, on this link, we need to prioritize the traffic, and we can prioritize the traffic on this trunk link. Why we cannot configure quality of service on single switch? On single switch, guys. See, when PC1 want to send some data to PC2, what will be the information there? IP header, IP header, Ethernet header, and switch will check what Ethernet header. By default, there is no any field available in Ethernet header for QoS. There is no any field in Ethernet header for quality of service. This is the reason we cannot configure quality of service on single switch. Then how we can configure on the trunk link? On the trunk link, you know, when switch forward traffic, it perform encapsulation of tagging. It will add the tag by using .1q or ISL protocol, correct?
Correct.
And in the ISL header or .1q header, we will have one field called QoS field. If I will talk about .1q header or ISL header, in both the header, you will find one field called QoS, class of service. And that QoS field can be used for prioritizing the traffic. That QoS field can be used for prioritizing the traffic. What is the length of this QoS field? Anyone? 3 bits. Length is 3 bits. You can capture the link and you can check .1q header. If you will check .1q header, you will find this QoS field, and in the QoS field you will see 3 bits are there. That means we can use these 3 bits to prioritize the traffic on the trunk link. Am I right? We can use 3 bits to prioritize the traffic on trunk link. And guys, by using 3 bits, how many combination can be there? I can
So
categorize traffic in, yeah,
0, 0, 0,
0, 0, 0,
then 0, 0, 1,
0, 0, 1,
0, 0, 1, 0,
हाँ,
0, 1, 1,
1,
1, 1, 1,
1, 0, 0 नहीं,
1, 0, 0, 1, 0, 0, 1, 0, 1, and 1, 1, 1.
how many decimal value you have to see? 1, 2, 1, 2, 3, 4, 5, 6, 7. Means we can categorize my traffic into 7 parts.
110,
1, 1, 0.
101, then 110.
Okay.
Yes sir, 8 होंगे sir.
1,
101.
100 के बाद में
Okay.
sir 110 आएगा sir.
अच्छा यहाँ पे yes 110. We can categorize traffic into, वही तो मैं सोचा कि आज ये कम कैसे हो गया, पिछले क्लास में तो सही था 8 था right? So I can categorize my traffic into 8 parts because I have only 3 bits for quality of service here. I have only 3 bits. Guys, the person who have created the quality of service have just given name to these all decimal value, right? Here decimal value is going to be what? 0. If all the bits are 0, then decimal value will be what?
0.
0. Here decimal value is going to be 1. Here 2. Here 3. Here 4. Here 5. Here 6. Here 7, right? These are the decimal value. And they have given one name to this decimal value. 0 is best effort. Best effort. which is the default one, right? If there is no priority, then all the bits is going to be what? 0. This is default one. If you have not configured the priority, then all your bits is going to be 0, right? If you will ping PC1 to this PC, any PC here on switch number 2, and you will capture the link, this trunk link, you can open the header, Ethernet header. In the Ethernet header, you can open the COS field, and in the COS field, you will see all the bits are 0. If there is no priority configured, then all traffic will go via best effort. All the traffic will go via best effort. The number 1 is called priority. Right? I will talk about this priority a little bit. For now, let me tell you the name of number 2. If the bits are 0, 1, 0, then it called as immediate. Immediate or immediator?
Immediate.
Immediate है ना? Okay.
Mhm.
Immediate. If bits are 0, 1, 1, it is called flash. If 1, 0, 0, this is called flash override. Flash override. If 1, 1, 0, this is called critical for voice traffic. Critical, this is called critical. And the sixth one means 101 is called internet, and this is used for your routing protocol, for your L3 protocol. If you will check EIGRP message, right? If you will check EIGRP message, you will find these bits, and name is internet. And the last one, 7th one, is called network, which is used for layer 2 protocol, STP, DTP, VTP, layer 2 protocols. Here I can say, instead of routing protocol, layer 3 protocol. I can say layer 3 protocol. Now guys, 0 means low priority and 7 means high priority. 0 means low priority and 7 means high priority. So see, layer 2 protocol will get high priority, right? And this one, the 7th one, is already reserved for layer 3 protocol. The 6th one is already reserved for layer 3 protocol. 6th one is reserved for layer 3 and 7th one is reserved for layer 2. And the 0 is reserved for best effort default. And we can use these all for our traffic, right? Like critical, let's say for the voice traffic, I set 110 bits, right? For the voice. For the FTP traffic, here I have set immediate.
Sir, I think हमने थोड़ा गलत लिख दिया है. 5 would be 101, sir.
5?
हाँ, 5 को सर अगर डेसिमल में लिखेंगे तो 101 we can write, right?
Yes, this is what I.
आप ही तो बोले हो जो, वही तो मैं बाइनरी में लिखा हूँ.
थोड़ा सा गलत हुआ सर.
ठीक है, सही.
0
कोई बात नहीं, उधर ध्यान ही मत दीजिए, बता देता हूँ इसको. ये समझाने के लिए था. अब डेसिमल नंबर पे ही हम काम करेंगे. बाय द वे, दिस इज my in binary. It is going to be 3 times 0, then 0, 0, 1, then 0, 1, 0, then 0, 1, 1, then 1, 0, 0, then 1, 0, 1, then it is going to be 1, 1, 0 and 1, 1, 1. ये सही है ना?
Correct.
ऐसे रहेगा बाइनरी में. Okay. So now you can see I have configured priority for FTP protocol and voice. And router will prioritize which traffic. Router will forward which traffic first. If router is receiving FTP and voice traffic at the same time, router will prioritize voice traffic, right? Because voice traffic has priority number what? 5. And FTP has priority number 2. This is called marking. Like on the FTP traffic, you are going to turn on these bits. If it is FTP traffic, router will turn on these bits. And till the destination, all the devices will be using this priority, right? Like it is not like you need to configure QoS on all the devices. My router is going to set this bit, the first hop, first router, and between source and destination all will be forwarding traffic on the basis of this priority, configure priority. Clear? So 0 means low priority and 7 means high priority, means it is going to work like this.
So we are
Low to high.
making basically classification or marking for 1, 2, 3, 4, and 5 only, right?
For all, but some are reserved.
6 and 7 are reserved. 0 is reserved.
Even critical is reserved for voice.
Okay.
By default, critical is reserved for voice. So you have flash over, flash, immediate, and priority. Waste effort is means there is no QoS, no quality of service. If I will use my lab, yeah.
So for voice traffic, we need to enable this 5th bit manually. We need to make on, or otherwise automatically it will be on.
Which one?
For example, I would like to
FTP.
know for voice traffic, bit number 5 critical.
For voice traffic, most of the devices are already performing quality of service. Depends on device. On my device, I think it is already enabled. For voice, critical priority is already configured. See, if you want to see it, you can check it in your lab also. Do you want to see the header?
Yes, sir.
192.168.1.7. Yeah, admin and if SD-WAN का लैब वाला एक्सेस ही कर लिया हूँ आपके लिए, चलिए कोई बात नहीं, ठीक है. For an example, between switch 1 and switch 2, guys, turn on the device. Lock the lamp. And if I will capture this link, switch 1, Ethernet 0/0. And let me configure the scenario till then. On switch 1. And here only we can perform L3 lab as well, like layer 3. Oh, I can do one thing. I can configure this link as trunk. On the trunk link, can I configure EIGRP? If yes, then tell me how I will configure EIGRP on the layer 2 link with the help of VLAN. With the help of VLAN, right, guys? I can create one VLAN here, SVI here for VLAN 12. VLAN 12 and VLAN 12 on switch number 2 also, and then I can enable EIGRP here. And these interfaces are in, let's say, VLAN 10. VLAN 10. Right, so let me configure the scenario like this. First, I am not going to enable EIGRP. First of all, let me show you COS field. Show interface trunk. Are you able to see? Trunk is already there, Ethernet 0/0. And which protocol it is using? ISL. I will change it. Interface E 0/0 switch port trunk encapsulation dot
1Q.
Right. Exit interface range E 0/1 to 2. I am saying switch port access VLAN 10. Right. And on switch number 2 also. Let me do this. Configure T and do so interface trunk. Trunk is already configured and encapsulation protocol is .1Q. Interface range E 0/1 to 2 and switch port access VLAN. Let me access PC, and on the PC I am going to configure IP, let's say 10.1.1/24. Gateway is not required. On this PC I am going to configure IP 10.1.1.2/24, and if I will capture this link Ethernet 0/0, are you able to see layer 2 protocol message, let's say STP? If I am going to enable the STP Ethernet header, guys, see, is there any field for quality of service, COS? For the QoS, is there any field?
No, sir.
This is STP instance for which VLAN?
Sir,
VLAN
we
1.
have only one.
We have VLAN 1 only. VLAN 10 is
No,
also there.
10, 10, 20 and 10, 10 and 1.
10 का भी तो रहना चाहिए ना. ठीक है, कोई बात नहीं. Let me do one thing. Let me send some ICMP packet. So क्या इतना open होगा? From PC1 I am going to say ping and 10.1.1.2. Ping should work. Ping is working. And let me open this ICMP packet. Let me take you to Ethernet header. Here it is, Ethernet header, and between Ethernet header and IP header I have .1q tag. Able to see? Are you able to see, guys?
Yes, sir.
And priority is what?
0.
Best effort. It is forwarding traffic on best effort. There is no priority for ICMP packet. No priority. If you will open STP instance of VLAN 10, I think VLAN 10 STP instance, here it is.
Yeah.
So you can see in this STP instance we have .1q header on the trunk link, and priority is
Best effort only.
best effort only. Let me configure EIGRP as well here. To configure EIGRP, I have to create VLAN 12 here, exit interface VLAN 12, and IP address, let's say 12.1.1.1 255.255.255.0 and no set. Go to switch 2 and let me enable EIGRP also. Config T router EIGRP S number 10 and network 12.1.1.0. Correct, guys?
Correct.
On router number switch number 2, config T VLAN 12, exit interface VLAN 12, no set, and IP address 12.1.255.255.255.0. Exit router EIGRPS number 10 and network 12.1.1.0. Now I will have EIGRP neighborship here.
Sir, EIGRP message would be traveling via trunk link.
Yes, and it will perform .1q header. See, but to form EIGRP neighborship, layer 2 protocol must be exchanged first, right? There should be layer 2 connectivity. So we have set which priority for layer 2 protocol? 7, you can see high priority. There is high priority configure for layer 2 protocols.
This is by default only.
This is default only.
Okay.
Right, for the layer 3 protocol it is going to be 6. And we have EIGRP neighborship. So in this case my switch should first prioritize L2 protocol, then protocol, then L3 protocol, and after that any user data, it is voice or FTP, anything user data. Before user data, EIGRP neighborship must be there, right? Then only route exchange will happen, right? So you cannot configure, you cannot define higher priority than to the user traffic than layer 3 protocol or layer 2 protocol, because let's suppose switch have traffic of user and EIGRP. If EIGRP message will not exchange, guys, the EIGRP neighborship will goes down if the hold down time will expire. After that, router cannot forward user traffic. Doesn't matter the QoS is configured or not. It will not have route even. So if route is there, then only user traffic can be forwarded by the device. So before configuring QoS for user, we need to prioritize L2 and L3, which is already prioritized in my case. If through ACL, guys, if I will block the, okay, we'll see that. For now, this is clear, right? And you have seen the cost filled in .1Q header. Similarly, like this, you will have cost filled in ISL header also. Now you can see the EIGRP message. If I will open the EIGRP message, here you can see in the .1Q header. Best effort, right? And in IP header, for the quality of service, in the IP header also we have one field called DSCP.
Sir, so in switch more than L2 or L3, we cannot define this marking this one?
No, what I am saying, the layer 2 should have higher priority than layer 3.
Yes.
And layer 3's protocol should have higher priority than any user. If I will talk about the end user, so again now we should have voice here. Voice, right? Till here everything is default. And now you can configure priority for rest all types of traffic like FTP, we can say HTTP, we can say SMTP, right? According to our requirement. Telnet, because Telnet is management protocol, Telnet should also have priority, etc.
So between these two switches, now where we configure exactly marking the voice traffic, high prayer?
On any switch you can configure, on switch 1 and switch 2. Just one. So guys, ICMP is used for troubleshooting, right? We are using ICMP for troubleshooting, and troubleshooting is so important on the device. If user is complaining that I am not able to access any server, so through ICMP only you are going to check connectivity first, that connectivity is there or not. So what I can do, see here 0 means this priority, immediate, flash, override are free. We can use it to configure priority to our traffic, right? So I can set bits for telnet. Let's say for an example 100. 100 means
4.
Right? Then I want after the telnet HTTP should have priority. HTTP means first router should process telnet traffic, then router should process HTTP traffic. So here I can set bits what 0, 1, 1. Then I want router should process FTP packet. Then here I can set bits what 0, 0, 1 like this. Getting my point? So let's say now router have these three traffic at same time. First router will process telnet. It will forward telnet traffic first, then HTTP and then FTP. It is going to work like this. We can configure priority according to our requirement. And for general traffics, I can set best effort, which is by default even. So let's say I have configured QoS for this traffic, and router is receiving HTTPS traffic, let's say, or SSH traffic. So router will use what? Best effort to forward SSH traffic. After processing these all traffic, router will put it in queue here after FTP. By default, all the traffics are using best effort. Clear? This is for layer 2. Yeah.
Okay. Configuration comments. Can you show configuration comments?
Yeah, I will show you.
Okay.
This is for layer 2. Note for actual traffic which is crossing the router. Right, like here in my lab, I'm talking about this link. Right, if the actual data is there, ICMP packet, you can see in the ICMP packet. ICMP packet is going with best effort at layer 2. Forget about layer 3. The user data doesn't matter, right? What is the user data now? At layer 2, it is going to check this .1q header, and in this .1q header, whatever priority is configured according to that, so it will forward the traffic layer 2 by checking this. If I will talk about layer 3, guys, so in IP header we have earlier we had one field called TOS. Which field? For layer 3, TOS. TOS stands for type of service. Type of service. TOS is 8 bits value. Length is the length of TOS field is 8 bits in your IP header. How many bits are there? 8 bits in your IP header. Right? So how many combinations are there? 2 power 8. And first 3 bits are used for QoS. First 3 bits are used for QoS, and rest all 5 bits are reserved. These are reserved. And again, by using 3 bits, we can have same combination, right? Reserved. And first 3 bits are called, what we call it earlier, IP precedence. Earlier we were using IP precedence in IP header for QoS. So first 3 bits are called IP precedence, and by using IP precedence we are prioritizing the traffic. Right? Again we will have the same combination 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. चेक करना सही है ना? In the IP precedence we have 3 fields, and again we have 8 combination. This one is called routine. This one is called routine, and this is exactly best effort. Best effort, the default one. Default.
This is for layer 3, right?
This is for layer 3. Yes. These bits are called priority. Priority. In layer 2 also you can see we are saying what? To the first value 1, priority. Here also we are calling it priority, exactly same. 101, immediate was in immediate.
Yes, sir. Immediate.
Next 011,
Flash.
flash. Then
Flash override.
flash override. Then
Critical.
critical for voice. Then
L3. Layer 3.
L3 protocols. All L3 protocols, name is internet. For all L3 protocol, layer 3 routing protocols, IP protocol, like that. And 111, L2 protocol, network, name is network, and it is used to prioritize L2. L2 protocol and L3 protocol. L3. L3. But this is old method, guys. This is old method. In the new IP header, you will not find IP precedence. So there is some difference change. Let me tell you that. Otherwise, the overall concept is same. The core technology is same. Concept is same. But this is old method. New method is called DSCP. IP precedence is old method. IPP, in short we are saying IP precedence. Right, new method is called DSCP. In the IP header you will find DSCP only. Here you can see at layer 3. If I will open layer 3 header, DSCP, are you able to see? The class selector and these informations are there, no, like congestion, for the congestion, and DSCP value at layer 3. And which model it is using? Differentiated service. Differentiated service, DSCP. Right? If I will talk about the length of DSCP, guys, see what happened in the new IP header. We have 8 bits for the quality of service in old header also and in new header also. Here also we have total 8 bits only. The length is same. But here we divide these 8 bits into 2 parts. In IP precedence, here also you can see in the toss, we have 8 bits and we divide it into 2 parts. First 3 bits and last 5 bits. Last 5 bits are reserved. Here again we have 8 bits and we are going to divide these 8 bits into 2 parts. First 6 bits and last 2 bits. First 6 bits and last 2 bits. First 6 bits are called DSCP. 6 bits and 2 bits. Right? So 6 bits, first 6 bits of the toss is called DSCP. What is DSCP? DSCP is nothing but the first 6 bits of your toss type of service, and this is called drop probability, ECN for the congestion. ECN, explicit congestion notification. Right? Forget about this last 2 bit. Just try to understand first 6 bits, which is DSCP. Now we categorize this first 6 bits DSCP into 2 parts. DSCP into 2 parts. First 3 bits and last 3 bits. Again you can see we come out at same point, right? 3 bits for the priority and last 3 bits. This 3 bits of the DSCP is exactly same like IP precedence. This is what? IP precedence, or at layer 2 you have seen the bits. It is exactly like that. What is this last 3 bits? Last 3 bits is called, guys, drop probability. What we called it? Drop probability. This first 3 bits is called class selector. Class selector, and last 3 bits is called what? Drop probability. Drop probability. Right? Now understand the class selector and drop probability. If I will talk about the class selector, so we have how many bits? Class selector. How many bits are there, guys, for class selector?
3 bits.
3 bits. 3 bits are there. And for drop probability?
Same 3.
Three bits. Now again in the drop probability we have 3 bits and the last bit is reserved. Last bit is reserved. So how many bits are there? 2 bits for QoS. How many bits are there? 2 bits for quality of service in drop probability and 3 bits in class selector. And the combination of class selector and drop probability is called AF. Combination of class selector and drop probability is called AF. The 3 bits of class selector is same like IP precedence. Like 3 bits of IP precedence. Actually we have just added 2 more bits here in the drop probability for the QoS, right? Earlier also we had 3 bits and now we have total 5 bits. 2 more bits are there from the IP precedence, right? So again in the class selector my value can be 000, 001, 010. Check करते रहना Rahul, please. 100, 101, 110 and 111. सही है?
Correct.
This is 0 and name is routine. This is 1 and name is priority. It is same like IP precedence. 2 and name is immediate. 3 and name is flash. Decimal value 4 name is flash override.
Naming convention is also same, huh?
Yeah, naming convention for the class selector is same like IP precedence. There is no difference, right? See, in the DSCP just we have added 2 extra bits. The class selector and IP precedence both are same. Here it is going to be critical, and after that we can say L2, L3.
L3.
First L3, then L2, right? There is no any difference. We don't need to discuss. Exactly same like IP precedence. It is exactly same like IP precedence. And now let me talk about drop probability. This is class selector, correct?
Yeah.
This is class selector. And in the drop probability, guys, 3 bits are there, 1 bits are reserved. How many free bits are there? 2.
Yeah.
So it can be 00 or 01 or 10 or 11. 4 drop probability are there. 4 drop probability are there, right? The 00 bits is called again best effort. What do we call it? Best effort. 001 is called low drop. What we call it? Low drop. 10 is called medium drop. Medium drop. And 11 is called high drop. This is used to limit the drop, traffic drop. packet with high value will drop first. If router need to drop the traffic, router will drop which traffic first? Who have the high value over here? High drop probability. This is
1 would be dropped. Huh?
1 yes. This is drop probability. Drop probability. Right. So total how many combinations are there? You can see, you can count. Right. Priority is going to work in this way. Higher value means higher priority, and drop probability will work in this way. Higher value means high drop. Higher priority means high drop. We can say like this.
Oh, sir.
है ना?
And other one is upward.
Yeah. यही सोच रहे थे ना?
Hmm.
Right. Now guys, what I told you, combination of class selector and drop probability is called EF, which we are using for quality of service. The last thing which you need to learn in QoS is EF. Combination of class selector and drop probability is called EF. EF stands for EF. As your forwarding. As your forwarding. Right? So we need to design one chart here to understand EF. What I will do, I will create one chart here in front of you. See, to calculate EF value, now we need to calculate EF value. Right? For that I am just going to create one chart. And guys, in the class selector, tell me which bits are reserved. This is already reserved. Am I right?
Yeah. L2, L3, and critical.
If I will talk about the free one, so see, 0, 0, 1 is free.
Yes.
Then 1, 0, 1 is free. 0, 0, 1 is free. And 1, 0, 0 is free, right?
Yes, sir.
That means number 1, 2, and 3, 4. 1, 2, 3, 4. These decimal numbers are free in class selector. And in drop probability, the first best effort is only reserved. Right? So free are
1, 2,
1,
3.
2, and 3. Here in this chart, this side I am going to write class selector value, class selector, and here I am going to write, let's say, drop probability DP. Okay, so class selector can be 1, it can be 2, 3, and 4. Correct? Drop probability can be 1, 2, and 3. So this will create one chart for me. Here we will get what? EF value. EF value. EF11. EF11 means?
1 combination.
EF11 means class selector is 1 and drop probability is 1. Here AF12, here AF13. Here AF14, 15, sorry, not 21,
Yeah,
22 and 23.
3.
31, 32 and 33. How many EF are there, guys? Now tell me, how many as you are forwarding forwarder
9.
are there?
9
41
till now. 41, 42, 43.
and 43. How many EF are there? These are
12.
your all EF, which you can use. It will calculate EF value by combining both drop probability and CS class selector. This is my class selector and this is drop probability. All the free class selector and free drop probability. And here you can understand the convergence also. Like for an example, if you have one IP precedence value, IP precedence, in short we are saying IPP, is 4. IP precedence value is 4, and I'm asking you what is the decimal value. How you can convert it into the decimal? Can you convert IP precedence value 4 into decimal?
100.
1, no. Yeah, 100, very good. 100, 100. This is my IP precedence. And if I will ask you EF, so what you will do here? You will add 5 unused bits here.
सर ये समझ नहीं आया 5 वाला कॉन्सेप्ट.
ये कैसे होगा देखिए. To find EF is how long, guys? How many bits are required? How many bits is there in one EF? 5 bits are there, na? 3 bits class selector and 2 bits drop probability. 5, right?
5 bits.
And if I have one IPP and I want to convert it into EF, then I need to add 5 bits, 50 here. This is going to be what? EFF. Right? And in the decimal, it will be what? 128. So IPP and EF both are compatible with each other. It will automatically add 5 times 0 here and can calculate EF value. Both are compatible. If I will give you the another number, let's say IPP value 5. IPP value 5. 5 means
101.
binary is going to be 101 and it will add 5 times 0 to find what? EF value. What will be the EF value? 160. Getting my point?
Yeah, 32 plus 120.
Yes. If I will give you IPP number 3, that means
011.
3 means 011, right? And 5 times 0. 5. Decimal value is going to be what? 96. So if I will configure 96, it will prioritize the traffic. It will set this bit there, and this bit is 3. 3 means you can see here
Flash,
right? So your traffic is in range priority. Router is prioritizing the traffic. Now next thing can be you can also see the convergence of EF into decimal. Let's say if you have any EF value, I am saying EF 13, and if I will ask you what will be the decimal value, can you calculate the decimal value, guys?
yes sir.
1011.
For first 3 AF you can say 1 is 001, and then
31.
for 2
31, 3 is what? Here 3 is class selector.
yes,
CS is 3 and drop probability is
1.
DP is 1, right? You know class selector length is 3 bits. 3 bits. So in binary it is going to be what?
0 1 1.
0 1 1. And drop probability is 2 bit. It is going to be what? It is going
0
to be
1.
what? 0 1, right? It is combination. That means my final value is going to be what? 0 1 1 0 1.
1.
Getting my point? And remember, in the drop probability there was one more field that is reserved. One more bits was there, right? So I will set that 0 here, which is reserved, which will be always and always 0.
Okay, at last that
And last,
reserved also
huh?
would be there. 0 is also there in that.
2 more
then.
0, right? And decimal value of this binary is whatever value you will find. 64.
Sir, why 2 more zeros?
If, see, from here 2 bits,
हाँ, correct.
so ये ECN bits ऐड कर दिया ना.
सर 2 का वैल्यू तो हमने ऑलरेडी निकाल दिया ना. 1 का वैल्यू 0 1 था, राइट?
अरे 8 बिट्स का आपका DSCP फील्ड था.
करेक्ट, टॉस फील्ड था 8 बिट्स का.
राइट, तो 6 बिट्स तक तो यहाँ तक वैल्यू आपने कैलकुलेट किया. 6 बिट्स ये है ना आपके. These are my first 6 bits.
3 उसके और 2 उसके.
हाँ.
करेक्ट. 5 ही तो है सर.
3 5 और 1 मैंने ऐड किया ना ये ड्रॉप प्रोबेबिलिटी में.
करेक्ट, रिजर्व्ड वाला
6 और ये 2 यहाँ पे है ना 2 बिट्स ECN के लिए वो ऐड करूंगा ना मैं. ये यहाँ पे ये देखिए ये 2 ECN है. These are ECN and then this is my ड्रॉप प्रोबेबिलिटी.
सर आई थिंक 1 और 0 आएगा सर.
1 और 1 आएगा ना यहाँ पे जो मिस कर दिया आपने. ये है, राइट? सो दिस इज योर क्लास सेलेक्टर, दिस इज ड्रॉप प्रोबेबिलिटी एंड दिस इज ECN bit, 2 ECN bit. Getting my point?
नहीं सर, कुछ गड़बड़ है सर.
कहाँ है कुछ गड़बड़?
सर 3 का पहले वी हैव काउंटेड फॉर 3, इट इज 0 1 1, करेक्ट?
0 1 1, ठीक. ये 0 होगा यहाँ पे.
हाँ, और 1 के लिए 1 के लिए होगा 0 1. 1 के लिए होगा 0 1, करेक्ट?
0 0 1 1 then 0 1
1
0 and 0 0. ये हुआ. अब सही है.
Correct. Now it is fine.
This is ECN bit, this is drop probability and this is class selector. Total 8 bit हो गया ना. DSCP has 8 bits, right? And the decimal value is going to be your 104. This is the decimal value if you will convert it. So कोई भी AF value मैं आपको दे दूँ 14. AF 41, right? You should be able to find the decimal value because we'll use the decimal value only in the configuration, right? So आपको what you need to practice? Convergence from IPP to decimal, convergence from AF to decimal, AF to decimal, right? And these all now guys we can categorize traffic into how many parts? 12
parts.
12 parts, right? And again the higher AF value is
Preferred.
high priority. It means high priority.
Means AF43 would be preferred.
Yes.
Okay.
AF43 have high drop. It will work like this, not like that.
Okay, 41 would be preferred.
41, 42, 43. After that 31, 32, 33. Then 21, 22, 23. Like this. Clear?
Okay.
Right? See, this is the class selector. So we are first prioritizing the higher class selector, which you already know in the IPP also, right? And the lower drop probability. Right? So that's why it is going to like this. So if two data are there, two types of traffics are there, one is using AF41 and one is using AF, let's say 31. Router will process which first?
41, sir.
41. And another side, AF41 and AF43. Router will prefer which one?
41.
41, right? So you cannot say higher value is more preferred. Here, preference is going to be this. Clear? Hope it is clear. If you want to see what you can do, you can connect two router here directly. And guys, you know, through ACL we can also block the precedence value. I can also block the precedence value. All the EIGRP message will come with what IP precedence value? All the EIGRP message will come with
110.
6.
Yes, sir.
It will come with priority 6. So on the router, if I will block IP precedence value 6, my EIGRP neighborship will goes
Down.
Right? So what you can do, you can create one ACL to block precedence value 6. And then you can see why my EIGRP neighbor is down.
सर एक्सटेंडेड एसीएल में फिर सेलेक्ट क्या करेंगे मतलब?
तो रिचेबिलिटी रहेगा लेकिन आपका EIGRP का नेबरशिप नहीं रहेगा. कमांड ये हो सकता है ना, एक्सेस लिस्ट 101 deny IP any and then precedence.
Okay. And then
Precedence value 6. Yes. And
Okay.
after that another ACL will allow all the traffic. So you will see I am able to ping the neighbor, but EIGRP neighborship is down. अब इस टाइप की ट्रबल शूटिंग तो आप नहीं देखे होंगे.
नहीं सर.
एनी राइट. जैसे यहाँ पे दिखाऊं, यहाँ पे तो चल रहा है ना.
हाँ ये EIGRP चल रहा है सर.
For an example on router number 2, I am going to say access list. First of all, if you will open any EIGRP message, here is EIGRP hello message. EIGRP hello message, and in the IP header, where is IP header? Here.
So opened here.
Right, here is DSCP field, and the value is, you
CS6.
can see 6.
लिखा भी आ रहा है सर ऊपर क्लास सेलेक्टर 6.
Class selector 6. Right. So if I will, class selector and IPP both are same, right guys?
Yes sir.
Class selector and IPP both are same, right? And these
Yeah,
two are
3
the
bits only.
ECN. Last bit, 6 bit over here, 2 bit over here, right? In this first 6 bit, first 3 bits is class selector and last 3 bit is drop probability, and first 3 bit is exactly similar like IPP, right? And as I told you, both are compatible with each other. So if I will block IP precedence, then EF value will be also blocked. Like DSCP, it can work with DSCP. So I am saying access list number 101 and deny IP any and precedence. Precedence value what? 6. Even here I will have option of DSCP also.
Toss
Yeah, DSCP is also there. You can match DSCP value as well directly, right? Like precedence number 6. I know the precedence value of EIGRP 6 because EIGRP is layer 3 protocol. And then access list number 101 permit IP any. क्या हो रहा है? Permit कहाँ गलत हो रहा है क्या कुछ? Access list number 100, access list number 101 permit IP any. कौन से इंटरफेस पे लगाना है ये ACL? Where you will apply this ACL?
SVI sir.
Interface VLAN 12 IP access group 101 and direction in. Clear? IP EIGRP 10.
neighbor.
neighbor. EIGRP neighborship is clear. So IP EIGRP neighbor. अब आप लाओगे पिंग 12.1.1 है, पिंग तो हो रहा है. सो आईपी
2 करो सर, 2
EIGRP.
करो. अच्छा, आज 2 पे आप.
सो
ठीक
आईपी EIGRP तो यहाँ पे इनेबल है, स्विच 1 पे भी इनेबल है, फिर भी नेबरशिप नहीं आ पा रहा है. तो भैया आपने प्रेसिडेंस वैल्यू ही क्या कर दिया है, ब्लॉक. राइट. सो पिंग
सर
एंड दोस ऑल
OSPF
थिंग
का क्या होगा देन? 6 ही होगा ना फिर, प्रोटोकॉल है बिकॉज.
सारे लेयर 3 प्रोटोकॉल के लिए सेम होगा.
ओके.
For all the layer 3 protocol, precedence value is going to be guys 6. And for
एंड
layer 2
ICMP के लिए?
protocol,
ICMP के लिए सर?
ICMP भी layer 3 protocol है.
अच्छा, तो सर ये
बट
पिंग कैसे आ रहा है फिर?
बट
अच्छा
अगर यूजर पिंग में क्या हो रहा है, पिंग क्या लेयर 3 प्रोटोकॉल ऑटोमेटिक जो काम कर रहा है वो प्रोटोकॉल है. लेयर 3 प्रोटोकॉल मीन्स ये नहीं कि भाई वो कौन सा प्रोटोकॉल यूजर यूज कर रहा है, वो तो यूजर यूज कर रहा है ना ICMP प्रोटोकॉल टू जनरेट ICMP पैकेट. आई एम टॉकिंग अबाउट ऑल द राउटिंग प्रोटोकॉल.
ओके.
Layer 3 protocol means all the routing protocol. Layer 2 protocol means all the switching protocol, ना कि layer 2 का यूजर डेटा. मैंने बताया था ना बीच में कि ये यूजर डेटा के लिए नहीं है. ये जो यहाँ पे हियर वी हैव सेट दिस, कहाँ गया ये, राइट. दिस इंटरनेट डजंट मीन priority for user data. For user data it is going to use best effort only, right. For routing protocol, layer 3 protocol, routing protocol here I should say, and here I should say layer 2
तो
protocol
सर
is
अगर हम
important.
लोग प्रेसिडेंस वैल्यू 7 अगर वहां पे सेट कर देते हैं तो ये पिंग आना भी बंद हो जाएगा बेसिकली?
नहीं, लेयर 2 प्रोटोकॉल सारे ब्लॉक हो जाएंगे.
हाँ, तो मतलब उसके बाद
जैसे
तो
आपका
सर
STP ब्लॉक हो जाएगा, STP ब्लॉक हो जाएगा, आपका
मतलब
VTP ब्लॉक
कम्युनिकेशन
हो
ही
जाएगा.
बेसिकली VTP बंद हो जाएगा, कम्युनिकेशन ही बंद हो जाएगा
क्यों
सर दोनों.
कम्युनिकेशन बंद हो जाएगा, VTP अगर यहाँ पे STP नहीं चलेगा तो यूजर बात नहीं कर पाएगा.
हाँ सर, DP पोर्ट कौन सा होगा फिर उस केस में, STP
अगर
नहीं होगा?
आपने 7 ब्लॉक कर दिए तो क्या होगा पता है, आपका
हम्म.
.1Q का जो नेगोशिएशन है वो डाउन हो जाएगा. फिर इंटरविलन लाइक लिंक पे जो है ट्रैफिक जाएगा नहीं यूजर का, इसलिए प्रॉब्लम
करेक्ट.
आएगा. राइट.
करेक्ट.
जैसे अभी EIGRP का नेबरशिप गया तो राउटिंग नहीं हो पाएगा ना अब,
हम्म.
वैसे ही अब राउट ही नहीं है तो कहाँ से राउटिंग करवाएगा ये स्विचेस, ऐसा इस टाइप के प्रॉब्लम्स. राइट. तो आपने पोर्ट अगर 7 IP प्रेसिडेंस वैल्यू ब्लॉक किया, दैट मीन्स यू हैव ब्लॉक द लेयर 2 protocols, DTP, STP, right. Route, both switches will say what, I am the root bridge, because they will not receive
BPD
BPDO
मैसेज.
message, right. अब इसी एक्सेस कंट्रोल लिस्ट में एक्सेस लिस्ट नंबर 100 and I am removing permit IP any and एक्सेस लिस्ट नंबर 100 डिनाई में 7 भी कर देता हूँ, राइट. एंड उसके बाद ये परमिट IP यानी वाला कर दे. देखो जैसे ही हटाया था EIGRP का नेबरशिप आ गया था. सो IP EIGRP नेबर, सो IP EIGRP नेबर. अभी होल्ड ऑन टाइम के बाद क्या होगा, नेबरशिप
डाउन हो जाएगा.
डाउन हो जाएगा. अच्छा EIGRP का मैसेज तो आ रहा है ना, EIGRP का मैसेज आ रहा है 6 इज अलाउ. सो एक्सेस
एक्सेस
लिस्ट
लिस्ट.
6 अलाउ है क्या, प्रेसिडेंस नेटवर्क
ये क्या आ गया?
6 अलाउ हो गया है.
सर सारे ही अलाउ हो गए सर,
हम्म.
सारे ही अलाउ हो गए. डिनाई
नहीं,
IP एनी
डिनाई नेटवर्क है ना,
ओके.
नेटवर्क डिनाई है. लेयर 7 protocols are, sorry, layer 2 protocols are denied 7, this one, right. So what will happen after 20 seconds, both switches will be the root bridge, both switches cannot exchange BPDO. So a spanning tree.
ये तो अभी तो चल रहा है सर.
अच्छा ACL हमने कहाँ पे अप्लाई किया हुआ है, ये तो देखो आप,
VLAN पे
यहाँ
करा
पे
है सर
VLAN
ये।
ACL चलाना, ये ट्रंक लिंक पे थोड़ी ना है ACL अप्लाइड।
एग्जैक्टली एग्जैक्टली।
क्या कर रहे हैं हम लोग। ओके VLAN ACL से, लेकिन ऐसे ही काम होगा। ओके फंडामेंटल समझ में आ गया आपको। Tomorrow I will show you the configuration of QoS. Right? Tomorrow at what time you guys will connect?
सर दिन में कर लीजिए, इवनिंग थोड़ा फ्री हो जाएगा, संडे मना
11
लेते
बजे दिन,
हैं। सर 12 बजे या 1 बजे सर, बिकॉज कल वो भी है सर
1
अपने यहाँ
बजे
पे।
से मेरा SD वैन का बैच है, कितने बजे में पता है आपको, 4 से 6, तो कम से कम 1 घंटे का तो रेस्ट बीच में चाहिए ना। चाहता हूँ
बिकॉज
3
सर
घंटे के लिए कम से कम बैठे, फिर बैठो तो। सो
कल
12
नवरात्रि
to
भी है ना।
12 PM
हाँ 12 या
is 12 fine for everyone? अगर 12 से है तो
Yes,
कल
it is fine.
12 बजे से, ओके ग्रेट, देन विल
12 is fine.
connect at 12 PM tomorrow. 12 PM, 12 to 3. Okay, so first I will finish the QoS configuration, and after that we'll start multicasting or IPv6, whatever you want first.
सर जो थोड़ा इजी पड़े, बिकॉज क्यूएस थोड़ा टफ पड़ेगा, तो इजी पड़े वो
QoS
वाला।
तो टफ नहीं था ना, QoS टफ था क्या?
थ्योरी है सर, इट इज टफ टू अंडरस्टैंड।
अब आपको EF ही सब सिर्फ याद रखना है, और एक बार आप अगर गो थ्रू करोगे ना, जाओगे ना, तो ये फंडामेंटल है, सेट होना है बस, कि भाई 3 बिट का ही तो खेल है सारे में, देखो आप,
बिल्कुल।
बस 3
तो
बिट
सर
का ही
ईएफ
खेल।
कहाँ पे आएगा इसमें फिर?
EF अपने को नहीं डिस्कस करना है यहाँ पे, मैं कॉन्फ़िगरेशन के टाइम में दिखाऊंगा आपको एक चीजें।